Yeah, and I
I hope
guess
we understand. I thought we do have the comments already, that the comment period has ended.
Yes, we do. We have written comments and we have responses to those comments, and those we will go over with the board members. I think what you're hearing today is that there are many people that don't agree with our changes and responses to comments.
Well, or that they're not clear enough. I have heard some things where it's just not clear enough, not just disagreement.
That may be, most of it is disagreement. They clearly know what we want. In many instances, they just don't agree. And I'm not saying that they're wrong. I think that we need to have a dialogue with the board on what they've heard and what their concerns are and what our response is, and how you'd like to see us change, if any, of those issues.
And I just wanted to clarify, my intention wasn't to mention that because there was a balance, we won't change it. What I was trying to explain, maybe I try again, is that when we were putting this order, the goal was to put a general order that actually the regions are going to use. So there was looking at what is it, the criteria that the regional boards are going to take the general order, and they're not going to make a determination that they need something more stringent. And it is appropriate for the type of facilities we're dealing with, and also be sensitive to cost and other factors that may impact. So that is all I was saying, that, many of these comments today we heard, we have looked at them, we will happy look at them again. We have a few new comments that we got today that we need to go back, as Jonathan mentioned.
I just know from the earlier briefing, I don't remember a lot of these comments being things we discussed at all.
Yeah, because we have a detailed response to comments, and we sort of provided kind of a big picture, but at the level of detail, we have detailed response to comments that is going to legal review currently. So we will have that, and we'll look at them again, but again, there is a balancing act between a general order that the regions find it suitable for their use, and it's appropriate for the facilities, and then allows them the flexibility to comply based on a site-specific basis. We always have this issue when you do statewide general orders.
And I appreciate that. Actually, that's an important point, because that was a part of my comment. Was I'd be interested in knowing what the regional board representatives think of doing any tiering shifts, or if they're more comfortable with, based on their technical evaluation, that 5,000 cubic yards a year we shouldn't go any higher than that. So I would be interested in knowing the board's opinion would.
And Member Moore, I just wanted to point out, we're talking about, have we got the right numbers for the tiers, and are these the right cutoffs and that type of thing. I just wanted to point out that was the purpose of tearing apart the last version of this order and sitting down with Region 3 and Region 5, Region 6 and Cal Recycle. That's where Ms. Farinack over there locked us in a room with the hummus and the donuts and said, work on the humus and two different things. And so that was the purpose, was to look at those levels and look at those tiers and make sure everyone came to consensus on what the right numbers were. So that's where we started with this version of the order.
Right. I don't want to negate the big changes you have made that you laid out right at the beginning. I mean, that's very significant, and many of the speakers have acknowledged that. That is significant. So it's a question of figuring out the final steps. I think. Thank you very much. Our science panel. Have we lost? We have our science guys? Okay. That's right. Oh. You want that one?
Okay. For the sake of moving things along, and we're the last two, I believe, and my name is Craig Kalagi. I work for a company called Summit Erosion Control. But prior to that, I was actually the Farm Advisor County Director for the University of California Cooperative Extension in Santa Clara County and the Superintendent of the Bay Area Research and Extension Center. And in that capacity, I actually, my job was to take the research from the university and extend it to the general public so that it actually had application. And much of my career as a plant pathologist has been in doing just that, and that is taking good quality substantive research and making it practical and applying it. So what I'm going to do today, I was asked by Dr. Britt Fawcett if I would fill in for him. He is the foremost expert on the application of organics for the treatment and management of stormwater quality and quantity. He's a graduate of the University of Georgia, got his PhD there in environmental sciences. He's written a number of publications. He's well published. Works for a company called Filtrix International out of Ohio and continues to do research with the US EPA and USDA. He published a book, and what I'd like to do in keeping this very brief, I do not have any slides, and I do talk fast, but the soil and water connection that you have in your hands there, and I have a stack of them in the back, was produced by the U.S. Composting Council Research and Education Foundation. And what it is, it was written by Dr. Fawcett, and it's a summary, very brief summary with a lot of pictures that talks about the connection between soil and water and the importance of organic matter in maintaining and managing and treating stormwater. Now, when I read through the actual fact sheet, as a good scientist, I always go for the facts. I want to look at them. I want to see what you're talking about. One of the things that struck me in reading the overview in that, we talk about fertility. As a plant pathologist, I understood the need for organic matter in soil health and good soil health. Good plant health, okay? I understood all that. What I didn't understand until 2009 when I started working with Dr. Fawcett for the last 6 years was the connection between organic matter and stormwater quality and how it connects to soil health. And in here, we talk about fertility, we talk about land diversion, but we do not talk anywhere in here about the use and application of recycled organics to actually treat and manage stormwater quality. So what I'd like to do with just a few minutes is bring your attention to this booklet and talk a little bit about the fact that this resource has roughly 25 years of research listed in here as references along with actual applications of the use of organics to manage the stormwater quality. And what's ironic is I've been to compost facilities on stormwater issues, and what I oftentimes see, and it's this disconnect that I'd like to address today, is that the actual compost managers, the operation managers, were using other tools other than the very compost in which they produce to control the quality of the water. And when I shifted them over to the use of their own materials, lo and behold, the quality of the water improved drastically. They were using things like gravel bags and straw bottles because no one had ever made that connection for them. And part of the University of California's mandate is to take this information, and it's what is sorely missing. So I challenge the board, I challenge the compost producers to start making that connection. This is a good start. I'm going to summarize here because, like I said, we're short on time. I want to summarize by just quoting Dr. Fawcett in the book. He says, "There is no singular solution to declining soil and water quality, but the most promising tool for this task is organic matter. And the most versatile organic material is compost." And I would like to summarize by saying we all need to leverage the power of this connection between soil and water to produce what we all want. And I'm hearing a lot of positive things here. I know we're struggling with the connections, but if we connect the dots, there's a tremendous potential here. We're at a time in the history of organic management. We definitely need more research, but more importantly, we need more practitioners. I'm up here actually because I'm on my way to be a trainer of record for the new industrial stormwater permit, and we have the mandatory training tomorrow in Rancho Cordova. But the reason I'm I'm doing that is simply because there's such a need for training. In this case, we'll be training the qualified industrial stormwater practitioners. We need people, we need resources to go out and educate the industry and the public on how we can do a better job. Thank you.
Yeah, you got there's the nexus with what we talked about earlier today.
I'm curious. I'm curious as to, and you can't really answer this, but perhaps Scott, maybe you can, or John, actually. If we thought the composters were going to sign up for the industrial permit, can they do that now? I mean, is that an option for them? Well, actually, that's not what was said earlier. It was said that there were only a small number. I forget what the number was, 4, I think. Do you know?
Well, I think the main reason is that the industrial permit deadline for signing up is July 1st. And so we are 2 weeks away, and
right.
Everyone tends to wait until
the
right
last
before.
So
it's
there may be
reality.
Okay, let's just say this fellow from Bakersfield signs up. Can he sign up for the industrial permit and not bother with the stormwater or with the
no,
compost?
that's not correct, because the industrial stormwater permit is designed to deal with just one aspect of the of an industrial facility for stormwater.
And part of the answer is it depends. So when I showed you the picture before and said, okay, this is the working surface where all the piles move around, that is what's being addressed by this general order for compost operations. If your facility, and we tried to do that as a cost-cutting measure. You know, if you could segregate that part of your operation and say, this is where we have to improve the pad and move those waste piles around, that would be your cost. If your facility is all contained there, you would have the general order. You may have a situation where part of your facility has your equipment and your compost showroom and other wash racks and other industrial type facilities that would need that industrial general permit. And so it's a possibility you would have both of them.
And in that situation, though, I don't remember who raised the comment, but someone raised the comment about the distinction between stormwater versus wastewater, calling stormwater wastewater. And that might have to be clarified for those that would choose to have both.
Well, again, we were attempting to do the operators a favor there, because the way the previous version was written, we had stormwater, we had wastewater, we had processed wastewater, we had non-processed wastewater, and so they said, it looks like you're regulating 4 or 5 different types of water here, and we can't figure out what to do. Why is it, you know, if it contacts the pile, then it becomes wastewater, but if it doesn't, it can be stormwater. So we were looking at that working surface and said, we can't manage if the rainwater falls in between and there was never a pile right there, then we can call it stormwater and it'll be clean stormwater, but if it contacts the pile, then it needs to go into the wastewater pond. So that was our goal, was to say, okay, look, we're not going to have 4 different types of water here. If it runs off the working surface and you've had rotting organic material out there, then you've got wastewater. But you could have a situation where part of your facility is not inside that 25-year berm, and that would be stormwater and subject to the stormwater permit.
And you'll make sure everyone knows how to handle that, right?
Oh, yes. By the way, Dr. Fawcett did say he's available if anyone wants to talk with him. And as am I. I left my cards in each of the publications there. If you'd like to use us as a resource to connect with the information you need to solve your problems, we'd be more than glad to work with you. There's a publication by Forrester Press out of Santa Barbara, California, called the Sustainable Site Design Manual that specifically addresses over 20 applications, all designed at stormwater management and quantity and quality, and specific focus on green infrastructure and low-impact development. So we invite you, please, to take advantage of of the information out there and our willingness to share it with you. Thank you.
Okay, thanks. I'll try to be brief. I'm Gary Anderson. I am a senior scientist at Lawrence Berkeley National Lab. I'm also the head of the ecology department there, and I am a professor of environmental science at UC Berkeley. So I'm going to talk a bit about compost today and some of the advantages of compost. Here I am down in Haiti with one of our collaborators on some composting working that we do. It has many advantages. You've heard some of these already, returning organic nutrients. And I'll get back into this organic part again in a minute, back to the soil for increased plant productivity. Increases water retention to soil. You've heard it before, but it's really important. And long-term sequestration of carbon. So what is compost? It's a decomposition of once living, that is organic material, to make soil amendments that's rich in nutrients. It's the humus part of soil. It's the organic part. So it's living. It slowly releases nutrients to plants. We manage the composting so the biodegradations happen faster than in nature and happens in a way which makes less greenhouse gases. It improves soil structure, texture, aeration, increases the soil water holding capacity. So I'm a microbiologist, and so I think of it in microbiology terms. Thermophilic composting, which is what I work on mostly, it's aerobic, so the microbes use air. The compost piles don't really have a smell. It's a rapid rate of degradation, elevated temperatures. The oxygen comes in, the microbes see all this carbon and nitrogen go wild. And so each one makes a tiny little bit of heat. And when you get trillions and trillions of them together, it makes for a hot pile. So what is the material? So there's two components. Carbon, that provides the energy for the microbes. So this is the leaves, the paper, the cardboard, whatever. So this is one component, and then the nitrogen. The nitrogen is needed for the cellular function of these microbes. So this is provided by either food waste, manure, grass, etc. It's also called greens. So the nitrogen here is from these different forms. It is organic nitrogen. So this is an example would be proteins. Proteins, our bodies are full of nitrogen because all of our proteins have nitrogen in. So these aren't something that are readily released into the environment. Carbon to nitrogen ratio is optimally somewhere around 30-1. So how does it work? You get the compost material together, mix the browns and greens in the right order, and you provide air and moisture, and you'll take off with activity pretty quickly. So within usually less than a week, you start to get pretty hot. And during that active composting phase, that's when the microbes are just going nuts. And so you go from the initial starting material, the microbes which have started this process, really changed during that first week or two. So all of the microbes, whether they were from the greens, from paper, from food, from manure, they all pretty much are gone during the active composting time, because once it gets above 50 degrees, they're all dead. And so these thermophilic organisms take over for the next bit of the active composting. That stabilizes after a while. It returns to a different state than it did in the beginning. More soil type of microbes are what remains.
Oh, on that graph, Dr. Anderson, is there any differential with these different phases of risk, of mobilization, of pollutants of concern? So, I'm imagining that if you have nitrogen bound up in protein going in, it's not as available for leaching, for instance.
Correct.
And then as you go through these different phases, is there a different risk of mobilization?
So it starts out small and it actually ends up being less. So the first stage, it's small. And then as it goes to the other forms, it actually it comes into a very stable compost form, which actually holds, I'll talk about this in a second, the electrical properties actually hold the nutrients in place. So it's much like, so at that point, and then by the time it gets to the ambient, it's like soil. So it does the same thing that healthy soil, not the chemically treated soil, but healthy soil helps to retain nutrients. So actually, the actual nitrogen during, since you brought it up, I'll just mention, because I heard it before, that, talking about the nitrates and the salts, and that doesn't happen as far as I know, because this is organic nitrogen. There are no nitrates, there are no salts in this process. So there's different types. There's the, swine or pig manure lagoons or something that do have problems, or chemical fertilizers, but salts and nitrates really aren't a key part of these compost piles. So just to, in the interest of time, going on really quickly here. So I have been involved with the Marine Carbon Project and the Nicasio composting facility in doing some experiments of my own on the composting procedures. And so in my lab, we developed a solution for looking at microbial composition and the microbes that are in different environments. And so I developed what's called a phylochip, which is a microarray. It's the thing, I should have brought one, but that's my thumb there. So that's about the size of it. And on there are 1.1 million different spots, different areas that have different pieces of DNA, which actually look for different types of microbes. So it's a very comprehensive looking of different types of microbes. It looks for specific sequences on them, and it can actually identify the individual microbes. If just a fingerprint on the bottom, that just represents different classes. That's of one type of source of material, where we see thousands of different microbes that came up, which I know are present from the phylochip, and they're relative abundance. So we can actually source different materials, compost, cattle waste, human waste, bird waste, for water quality, for many sources. We actually looked at this on compost pile to look at optimization during the course, going from initial types of material up into different thermophilic organisms. So a colleague of mine at UC Berkeley has also worked on this Nicasio location, and I just want to, even though it's been mentioned before, I want to very briefly just state some of her highlights in a very elegant experiment that she and her students did, which by spreading a centimeter of compost on different California grasslands, they identified a significant increase in plant productivity and water retention. And what they found, which is the most important, which you keep on hearing over and over again, but this was the first time it was scientifically shown. Again, that's very important for us, not for anecdotal, but to have scientific studies to show something before you actually come and say that, it does this or it does that. And in this case, a very good proof that long-term storage increase of 2 tons, metric tons are about the same as English tons per hectare. And so an additional 2 tons each year of this very microbial resistant carbon. So actually holding carbon into the soil, whereas when plants die, they release their carbon, it goes up to the atmosphere, plants make carbon, and it's just a cycle. This is a way of actually retaining carbon. So some of the work that I've been doing, and Wendy was on Dr. Silver was on a recent TV show, a nationwide one, Food Forward. So just on your own free time, there's the link there, but just go search Food Forward PBS. We're episode 4. It actually is entertaining. It's not something that you would not like. You would actually, if you're talking about, this is a whole 22-minute episode on composting, but it's very entertaining. It was for a nationwide audience. So compost and soil health, again, this is with our work in Haiti, where very degraded soils, and we're applying compost and seeing good nutrition, nutrient-rich food. And I won't get into this audience of the detail of cation exchange capacity, CEC, but this is the basis of some of what I'm talking about, just the electrical interactions. Up on the either of, I can't show, but that clay particle, the brown thing in the upper right, it's negatively charged, and because it's negatively charged, it can take positively charged anions, these different elements, these that are important for nutrition, the magnesium, calcium, and as well as nitrogen. And so it holds these in place and then very slowly releases them into where they're the plant available into the root cells. What happens, what's different in compost or the humus layer of soil is that you have much more than just clay. So the clay by itself is very ineffective. And so what you have instead is the organic material has all sorts of reactive functional groups, the carboxyls, hydroxyls, phenolics, which provide a much better, higher cation as well as anion exchange capacity. This is what increases the water holding capacity. This is what promotes soil aggregation. And what's important here then to remember then is it seems like up till now, it's from what I've heard, the nitrogen is not talked about in the right way. So nitrogen is in several different forms. It's in organic form and it's in inorganic form. For plants to grow, they need to have inorganic nitrogen. So it's actually the nitrates, the chemical nitrogen needs to is what's present to make plants grow. But what compost has, what soil has, is carbon and nitrogen, which is slowly released. And so the slow release is key to plant health and to healthy soils. So I've summarized some of that here, the difference between reactive nitrogen in liquid manure or chemical fertilizer versus organic nitrogen in compost. So it's available to plants as either ammonium or nitrate. So these are the inorganic forms are commonly found in chemical fertilizers in liquid manures. But the organic nitrogen in plants and compostable materials is actually very stable. These forms of nitrogen are not available to plants until they're broken down. And they're broken down over years and decades. So it's a very long process. The nitrogen exists in the compost and soil humus as stable organic nitrogen. The breakdown to inorganic nitrogen occurs over a long period, as I just said, and the release is about the same rate as what's taken up by the plants. What I saw in one of the first, I don't remember, one of the earlier presentations was showing some brown liquid at the bottom of the compost pile. And, oh, that must be really bad. And it's probably killing all of the microbes and everything there or creating big microbial blooms. And I would challenge that because actually what it probably is mostly complex organic nitrogen. Which is not that readily available, which will slowly break down over time, but in a way which has been going on in nature for years and years. It's much different. Wastewater versus an effluent like that, where even if the microbes see it, it's going to be a long time before they destroy it. So I just wanted to make that a very clear point at the end that these are very different forms. So reactive nitrogen, things in wastewater are very different than what's in compost. So that's very important when it's assumed that anything that coming from a compost is going to degrade different types of groundwater or streams or things like that. Because
and you're saying that no waste ever gets into compost in any of the composting facilities we're talking about?
No, I'm saying that as I was saying before, it's the fraction. There's a fraction of that which is being converted into a reactive inorganic form. So yes, so compared to different types of like ammonia waste and things like that, it's much more stable. And so the whole process of composting creates this very stable product. And and once you're in the end stages of compost, yes, that material, it's like, yes, there could be some damage, but just like if soil goes into a stream, I would say compost finished compost and soil are pretty equivalent. They're, as far as damage for, if it's done properly for thermophilic composting, for microbes, for nitrogen, for things like that, it's about the same as soil.
We're not talking about if it's done properly, because I suspect you're right. But we're talking about if it's just, you know, done the way people do things.
Right.
It's a range of properly and not
Right.
properly.
So it's, yes, but that's,
So, I mean,
right.
I just want you
No,
to,
it's fine.
to acknowledge that there's a reason that we're here.
No, absolutely, there's a
It's not
risk,
just
but-
frivolous,
yeah.
right?
Oh, no, I didn't
Okay.
say that. But
Okay.
I would, that's why I made it the point of showing the ingredients that go in. They go in as very low reactive nitrogen, and they only get less as time goes on. So it's just to be very careful in assuming parallel that source, even if done improperly, it's like, at worst, it's like land application of, that's kind of what you're looking at. Thank
Going
you.
to have a different impact.
Thank you.
Still concentrated activity, you know, in a certain area. So,
Yes.
you know, like that Bakersfield facility, it's still a lot of that compost. So there's still a mass of nitrogen that could be significant if mismanaged. Yeah.
But I guess my point was just that although it's a lot of nitrogen, but it's just it's a lot of different forms of nitrogen. It should be looked at in its totality.
So they would have a different impact as they percolated through the
Exactly.
soil. What
And
I
so-
hear you saying is it would just become the soil, whereas, say, nitrogen fertilizer, applied chemical fertilizer, or something else would speed through faster and have an
That's
impact.
exactly what
That's
happens,
what I heard you
yes.
saying.
So that's what's known to be different. That's when you put chemically apply fertilizer. That's what happens in the Central Valley. It goes rapidly through. What doesn't get, it's like, so I could put an analogy. So chemical fertilizer is like candy, and compost is like broccoli or carrots. And so everything is eating really quickly. My kids just love the candy as it's going down and just bypassing the carrots. And so it's that the nitrogen, chemical nitrogen, just goes right down into the groundwater. On the other hand, the organic nitrogen takes a slow time going down, and it never makes it to the groundwater.
I think the point's been, how about the manure? You know,
So that needs to be studied more. And I think I mean, I must admit I'm new to all of this. I've actually never been to Sacramento before, to tell you the truth. But it's,
welcome to Sacramento.
but thank you. But I think that, you know, from what I've seen so far today, you know, we've been doing some study, but, you know, we do everything as evidence-based. And so hopefully there's a lot of studies that are backing things up. Yeah.
I'm just curious what went into the development of the order with respect to this information.
It went into what?
The development, I'm looking at Shala. What went into the development of the order with respect to this information? Or was a different
So,
scientific approach used?
no, we monitored leachate from coming off of compost piles and found contaminants in it. We have that information. I'm sorry it's not here in front of you right today. So I'm listening to this gentleman, and I think that's very interesting. I don't know what the difference is between the piles that are out there, that have been monitored, that have contaminants in there at high concentrations, and what he's found in his scientific studies. So,
And then you're talking about nitrates, but then there's
Right.
also metals and pathogens.
And so you're finding nitrates and that at certain concentrations.
So I put up the offending slide, I believe. So I will admit that I do not use or may not have used the different forms of nitrate in their proper sequence. I'm not a geochemist. I'm more of a fluvial geomorphologist, if you wanted to know. So, but we have those people, and we can get them here.
I guess I could just echo that. I could always help out too. I mean, you know, at Berkeley, we're good at being experts at things, and so, yeah.
Yes, we are.
Anyway, you may now have the quote of the day.
And
I
we-
can't remember what the other quote of the day was.
And we want you to come back to Sacramento.
Yes, we do. We do want you to come back. All right. Any other questions? All right. Thank you. We have a number of comment cards, and hopefully from the number, maybe they're all still here, as opposed to having lost them along the way. Thank you all for staying. And we're going to do it at 3 minutes, Courtney, if you don't mind, because it's late.
So our folks from Region 5 are here with the sampling information that they collected, if you'd like to hear it.
Okay.
Yeah, that's the pudding that we talked about. where the
Hi,
proof
Chair
is.
Marcus, members of the board. Andrew Altsvogt. Oh, I think it's green. I'm Andrew Altsvogt. I'm Assistant Executive Officer with the Central Valley Water Board. And I did want to address some of the claims that have been floating around about, the impact of compost and leachate and all those things. And first of all, to say that, we don't disagree that compost is a good thing, but leachate can be a really harmful thing to groundwater. And so, as Ms. Creedon mentioned earlier, we only have maybe 5 sites that are currently permitted in our region out of 55 plus. And so we do have just limited data from those sites. But what that data shows is that in the leachate itself, we have total dissolved solid concentrations up to 24,000 milligrams per liter. We have ammonia levels that we've seen up to 2,000 milligrams per liter, sulfate up to 26,000 milligrams per liter, so very, very high concentrations in the leachate. And then as far as I think there were some comments made on nitrate in particular, the 2 sites that we have nitrate data from in the leachate, one site was 14 milligrams per liter, and the other site, which when the samples were taken, it was actually right after a storm, so diluted with storm water, the nitrate was 6.38 milligrams per liter, so still fairly high, and that's diluted with storm water. And then as far as, I'm just looking at my
And that's
numbers
as
here.
nitrogen, so the 10, you're comparing against 10 or 45?
Comparing against 10, yes. And then as far as groundwater goes, again, we limited samples, but we're seeing TDS up to 3,400 milligrams per liter, and nitrate up to, depending on the site, actually nitrate up to 47 milligrams per liter next to some of these sites. So, I mean, I think the numbers do actually speak for themselves. For the, again, the limited data that we have shows that yes, indeed, not only is the leachate a concern, but it's entering groundwater, and it's causing degradation and pollution in groundwater.
But as you look at it, so you have 5 that are permitted, just for the sake of
Sure.
argument. So you have 5 that are permitted, you see a problem, no wonder you're concerned. Some of the people here today have talked about how there are facilities, or they allege there are facilities that don't have those problems, right? There are good facilities and bad facilities. And do you feel that this order gives you enough of an ability to not paint them all with the same brush, but to exempt them if, say, you had one that doesn't produce anything that you're concerned about?
Sure. I mean, my understanding of the
No matter
order,
how big they are.
yeah, and we'd have to go start looking at the facilities, see their reports of waste discharge, and and understand that a little bit better. But my understanding of the order is that we have a good deal of flexibility to reduce some of the requirements based on those reports of waste discharge. And so we feel like, in fact, it does give us that flexibility to deal with those situations and to make some site-specific determinations where appropriate.
Right, and you have a card, so you'll be back.
Well, yes, I can.
Waiting your turn is a good thing to do as a regulator. First, we have Kathy Lynch. Thank you. Followed by Dan Noble.
Good evening, members. Thank you very much. I'm Kathy Lynch, and I represent CRNR Incorporated. And for those of you who don't know, they're a full-service recycling and waste management firm down in Southern California who serve over 50 cities down there and 2.5 million customers. They're one of the very leading edge of developing anaerobic digestion systems to convert waste to renewable energy and transportation fuel. So this is all very exciting to them. I had a lot of various comments. Many of them have been addressed earlier today. We do want to affiliate with a coalition letter of composters and waste industry participants and environmental groups that filed some recommended language changes. I would like to just acknowledge the staff for making some modifications to the language pertaining to the anaerobic digestate in the May 29th modifications. One area that we would like to see further refined is the arbitrary limitation on the certain types of additives on page 18 and 19 of this draft. We again would look for some local regional discretion to consider additives in excess of the arbitrary 10% number for Tier 1 and the 30% for Tier 2 facilities. Again, obviously, with the underlying water quality goals achieved, we would like to have the flexibility to use non-hazardous additives in their processes. So this is our primary concern, along with, again, the flexibility that you've heard a lot about today, and we're happy to continue to work. We really appreciate the conversation with the other state agencies. We think this is really critical. This is one of the biggest concerns we have overall, is really appreciating that you have Food and Agriculture here to talk about healthy soils and CalRecycle, and trying to mesh definitions and making sure that this is a whole system that works for us. And I really want to appreciate what you've offered tonight by providing this workshop time, and we hope that you'll provide a little more time so we can get this right. This is very important policy, and many of the companies have already invested a lot of financial resources in this effort. So thank you.
Thank you. Helpful. Mr. Noble, followed by Veronica. I can't read it. Looks like Pardo. You'll correct me. Yes.
Hi, Dan Noble, Executive Director of the Association of Compost Producers at healthysoil.org. So we obviously represent both public and private composters throughout the state, and I just want to underscore and echo a lot of the comments that were already made relative to the economic analysis, relative to the notion of calling all the water wastewater, because that seems to muddy the waters was the only term I came to mind at this late hour. I think there is some real distinctions between whether the nitrogen is in one form or another, and that's not well known. If it's just present, that doesn't necessarily mean it's a pollutant. It's really how it migrates. And we already heard some confusion about stormwater versus going into the groundwater. And we also talked a lot about, you heard a lot about the need for flexibility in various soil types, soil depths, amount of rainfall, and so forth. So when we talk about the flexibility issue, I'm wondering if this general order doesn't actually make it more challenging rather than less challenging than the current situation. Maybe a different approach might be to actually offer guidelines for the individual regional boards rather than a one-size-fits-all. Because my understanding of this order is that you're setting a lower limit on the pads being 10 to the minus 5 and the ponds being 10 to the minus 6. And it's just about the flexibility of the size of the ponds. So if that becomes the floor, then that means all compost facilities are inflexibly have to go to that, or they go to a monitoring process. So,
or they're exempted at the beginning. It's not having.
They're exempted at the beginning. So
engineering alternatives.
Or engineered alternatives.
Right. So
lots of choices.
So I'm not sure how that general order actually makes it more uniform. It makes it easier for the individual boards if you or the composters. You still have to go through that process, correct?
You have to go through some. The alternative is not the current system. The alternative is 9 different ways.
The fees are lower.
Especially if you're going to have an explosion of facilities, then all of a sudden you have to permit them all. I mean, so the current won't, whether we do anything or not, the current won't last, the current situation.
Right. So we do remain available to continue working with staff and with the scientific community and with the healthy soil community to determine if this is truly a cost-effective solution to the problem to protect groundwater. So thank you very much.
Thank you.